Okay, we're going to pick back up here with number 5. We want to verify. It looks like the left-hand side is going to be a little bit more complicated, so we're going to start with this side. My first hint to you is to rewrite all of these in terms of sine and cosine, and let's see what that looks like. So that's your first hint. Pause it and do that. Alright, so I did that, and I'll look at it, and I just want to process. I have this information. It's not really any other way I can rewrite these or rework these, so this is kind of what I'm working with, but I know I need to get to my right-hand side. Let me go back and remind myself of some of my techniques. Rewrite the more complicated terms. We did that. Okay, there's no GCF to factor out. This isn't going to work for it. Least common denominator, we can consider that one, and we can also multiply by a factor that appears on the other side. Well, let's get back there. A common denominator doesn't seem like it would make things any more simplified or possibly get me there, but what is cotangent in terms of sines and cosines? Your cosine over your sine. What would make this cotangent if I have what in the numerator? Cosine, go. What happens if I had cosine in the numerator here? It would simplify to 1. So what if I had cosine here? Cotangent, and what if I had cosine here? So we can multiply by a factor. In this case, let me see if I can multiply this by the numerator by the cosine of x. Let me move that equal sign. So multiply the whole thing by the cosine of x. Whatever you do to the numerator, do to the denominator so that it doesn't change our value. Okay, and then so basically we want to distribute that out. So then that would just, and I'll rewrite the steps so that you can see it. So it would be cosine of x over sine of x. I'm going to pause it. So distribute this cosine out to all of those terms. Okay, so once I do that, this now simplifies to cotangent of x, and this is going to simplify to just 1. And the same thing in the denominator, cotangent of x minus 1, which that's what we were looking for, so verified. So in this particular case, this one is where we multiplied both sides by factor, which was cosine of x. Okay, so 6. Yeah, we look at this and we literally just think yuck, but we look at our left hand side. It's obvious, looks like a lot more is going on, so we'll keep our goal in mind. Let's see what happens. First of all, I'm noticing that this is how many terms? 2, right? What about my right hand side? We got this and this, but this is kind of combined, so I'm going to use the get a common denominator. So let's get a common denominator with these. So what's the common denominator with these two? Secant theta, tangent theta. So let's do that for this step. Okay, so we put that over a common denominator. Make sure you get caught up with that. The next thing we want to do is we want to distribute. Distribute here and distribute here. So take a minute, pause it, and let's go ahead and do that step. Okay, so once we distribute it out, I'm left with this. This particular term right here, if you wrote tangent theta then secant theta, that's fine. Multiplication is commutative, so it doesn't matter the order. Now what we do want to notice is that we have some squares, and let me see if I can highlight this in any kind of way. Tangent squared, secant squared theta. Pythagorean identities, when we have 2 of them in there, let's go give some attention to that and see if we can simplify anything. Okay, on your formula sheet, if you find the Pythagorean identity, tangent squared theta plus 1 equals secant squared theta, and you solve that identity for 1, it means you would have secant squared theta minus tangent squared theta. So basically, our highlighted stuff just simplifies to 1. Now, add like terms. Let's just say I call this guy x. This is negative x plus a negative x. What would that give me? Negative 2x. So I just want you to see that it's like terms. So it's going to be just minus 2 secant squared theta tangent theta. And the only reason I did that is sometimes people get confused. This is just like terms. When I said like this would be negative x plus negative x, and you would say, oh, well, that's easy. Add like terms and you get negative 2x. Well, it's the same thing. Secant theta tangent theta is a like term to secant theta tangent theta, so negative 1 would give us negative 2. So that's sometimes not as obvious as it should be. And then, of course, we're still over our common denominator. All right, let's remind ourselves where we're going. Cosine theta, cotangent theta minus 2. So now let's break this up into separate fractions. So our first one is going to be this, and then our second one will be this. And write those down. Okay, well, what's 1 over secant? Cosine theta, good. What about what's 1 over the tangent? Cotangent, good. And then this will cancel with this, so we were just left with minus 2, which equals our right-hand side. And we're done. So, okay, we're actually finished with the lesson there. I'm going to add 2 extra examples, number 7 and problem number 8. I'm just going to probably write those up there and let you work them out and have you have the work for them so you can look at them just as extra to try on the side. So that's going to be for 7 and 8. So write those down, try those on your own time. I'm just going to pretty much work them for the video and pause it, give you the solution so you can look back at it as a reference. Okay, so you can check your work on number 7, and then we're going to do the same thing with number 8, and you can check your work with this one. Okay, the tricky thing about this one is first of all, you use your Pythagorean identity over here and replace this with cosecant squared theta minus 1. In this particular case, this may not be as obvious to you, but when I do it using an x, so let's think about this for a minute on a side note. This actually factors out to be x plus 1, x minus 1. Well, we have a similar thing going on over here, but it's just a trig function. So it's cosecant theta plus 1, cosecant theta minus 1. So that might not be very obvious to you. These will simplify, and we're left with this, and of course the ones cancel, and it's verified. So those are a couple of extra ones to look at. We're going to go ahead and move to the next section now.